So today's lecture is on assignment 1 and how to set up the C++ programming environment. It's going to work just fine in Linux, Mac, and Windows. If you have something that's other than that, I'm not sure what planet you're living on, but please get one of those things. If you do have one of those things and you can't afford another system, it's fine because you can go to the senior lab in the engineering building. I believe it's EN 2036, and you should have all have access to that. You log in with your LabNet account, and you can just run the Linux instructions here. Okay, it's already set up for you. So if you are doing your assignments in the lab, don't do any of the setup part. Just do the part where you download your assignment and compile it and stuff. A quick note: since the last lecture, we did end up reorganizing the course a little bit, and I'm just going to take a minute to explain that. Let me turn this off for you. So up here, you can see that there used to be, lecture 2 and 3, there used to be 2 lectures on C++. And what I noticed is that because the second lecture on C++ was supposed to be today, so there's only 2 days difference between Tuesday and Thursday, but there's 5 days difference between Thursday and Tuesday. And so what I did was I sort of deleted the second lecture on C++. I put that video of both lectures of C++ into one lecture, and then I put that on YouTube. And because lecture capture ended up not working, I used a previous lecture that I had recorded, which is actually much higher quality, and that lecture ends up being 4 hours long on an intro to C++. So if you know C++ already, you don't necessarily need to use that, and you don't necessarily need to watch that entire video right away. But if you've never used C++ before, I do recommend going through that video because it'll give you all the knowledge you need to know on C++ for this course. And why did I do that? It wasn't just to make things more confusing, because over here you can see that now we have 7 days more to work on the project than we did before, just because of eliminating one lecture. So the combinatorial effects that we see from moving lectures around actually is important, right? And it's the opposite of this if we have things like snow days. So if we have a snow day somewhere and we end up missing a lecture, which we won't in this course, then it could eliminate a bunch of days from a project or an assignment. And so that's why it's so important that we're not going to be missing any lectures in this course. So any questions about that? Essentially what happened is the whole course just moved up by 5 or 7 days depending on the assignment. So all the assignments are going to be released sooner, but they're also going to be due sooner, so that we can get it all over with and have more time for the project. Okay, so today, as I said, is about assignment 1. And what I'm first going to do is go over the files that you'll get in this assignment. So again, I'm going to be emailing you links. So you'll get an email at your MUN email address, which it's just a single email with all the links to all the assignments. And so the assignments will not be immediately available upon getting that email. Like, you're not going to be able to download assignment 4 right away. But what will happen is typically the day that I give the lecture about the assignment, by the next morning when you wake up, that assignment will be available to download. Okay? Because what I want to do is I go over everything in the lecture, and then I spot any errors that I may have made, and then I spend that evening fixing them, and then sending out or uploading the assignments, and then they'll be available. So I'll make an announcement on D2L and on Discord when this assignment is available, but it'll be there tomorrow morning. I'm sure all of you were super excited to start working on it immediately after class, but you'll have to wait for tomorrow for that. So when you download the zip file, you're going to get a structure that looks like this. So I've just extracted this into A1, a folder. So you're going to see a bin directory, a source directory. You will not get the solution source directory. This is just from my sort of courses GitHub. So I keep them all in one folder, but you will not get this source solution directory. You'll get a Visual Studio directory, and then you'll get several files. So this bin directory is where the compiled versions of your code will go. So Visual Studio and the make file, once it compiles your program, the executable will just go into the bin directory. So bin stands for binary. Also in the bin directory, you'll see here a fonts directory. So when you want to draw things to the screen with SFML, you actually need to have a font file that you load to draw it. So that's where that's located. You'll also have a config.txt file. And this config file is going to be the thing that you'll use in your assignment to actually draw the things to the screen that I want you to. And then you'll have this imgui.ini file. And what happens with the imgui library, whenever you move it around or you make changes, it just writes to this .ini file, and that's in the bin directory. So you'll have one of those as well. So that's the bin directory. In the source directory, you'll see all the source files that I've given you. And basically, the only file that you need to worry about for this assignment is main.cpp. Let me make sure that OBS is correctly. Okay, so it's correctly recording the sound. Just want to double check. Okay, so main.cpp, that's where all of your source code for the first assignment is going to go. So it's a simple enough assignment that it's just one file. That'll change in future assignments. And the other folder you'll see in the source directory is the imgui library. And I've just included that for you because it's easier to do it this way. So whenever you compile your code, it actually compiles the imgui library and links it into your executable. So you don't need to worry about installing the imgui library. But if you never open that folder, you'll be fine. The only source code you need to worry about for this assignment is main.cpp. Next, you'll see the Visual Studio folder, and this will have several different files. The main one is sfmlgame.sln. So the way Visual Studio for Windows works is that there are solution files and project files. So here you'll see this is a project file, and a solution file consists of one or more project files. So you can have multiple projects in the same solution, and essentially in Windows, and I'll show this all at the end of the lecture, you just double click the solution file, it opens it up in Visual Studio, and then you hit compile. So that's nice. And then you're given a marks file. So the marks file is a detailed marking scheme for the assignment. With my assignments, I like to be as detailed as possible in telling you what I expect, and you should, in response, be given as detailed as possible what you're going to get for doing these things, right? So by the time you go to hand in your assignment, you can pretty much determine what your grade is going to be from this. And I'll go into that a little bit later. I also have an assignment setup.txt file, which goes through how to set up everything for all three operating systems. In this lecture, I'm first going to go over the assignment itself, and then I'm going to judge how much time I have left after doing that, because that's the most important part. And then I'll use all of that remaining time to go over the setup. The setup is actually pretty easy, so it shouldn't take too much time to go over, but I will be doing the setup at the end of this lecture. Then there is a make file, and I will go through the make file with the setup, but just let you know, this is how you would compile it in Linux or on Mac OS X. So you just type make, and it will compile and run everything for you. And then there's a README file, and this contains the exact specification of what I want from you for this assignment. So typically, when it's an assignment release day, what I'll do is I'll first open up the solution of the assignment, the running solution, not the solution code, and I'll go through what it should look like when it's done. And then, after I've shown you what it should look like, I'll go through and painstakingly read the entire README file with you so that we know exactly what you're going to have to do for the assignment. And if I spot any mistakes in that, I can fix them before I give you the assignment. So that is when you get the zip file, you're going to extract it, and you'll get all of these files except the source solution directory. So that's I think that's pretty easy to understand. It's not a complicated setup. It's just one folder with several folders inside of it. So just another quick poll. So who's going to be using Windows to do their development in this class? Okay, so probably like 80% of the class, it looks like. And Mac? Okay, and Linux? Okay, so Mac and Linux, probably about 20% of the course. Because I'm using a Mac here, I have some virtual machines, which I can show. So this is Linux, and I have Windows running here, so I can go back and forth through them. But very annoyingly, because of virtual machines' interactions with Windows scaling, and the fact that MacBook Pros have this ungodly high resolution, whenever I run the game in Windows in my VM, the window is super tiny. And so because of that, I'm going to be doing all of my demo stuff in the Mac version, okay? So I'm going to be doing, this is running in the Mac in VS Code. So So that's why I'm running it in the Mac. I know that most of you are going to be using Windows, but there's really no difference other than the fact that when I go to compile it, I'll be typing make, and when you go to compile it, you'll just be hitting compile in Visual Studio. Okay, so there's no big difference. But I'm just explaining to you why I'm using a Mac instead of Windows for that. So what we're going to do first is I'm going to come over here. So I've already got my code extracted here, and let me clear that out. And I'm just going to type make run. So if you're on Mac or Linux, the make file, you just type make run, it will compile it all, and if there are no errors, it will run the program. So let me type make run. This is it compiling all the different CPP files, and these are the IMGUI library. And so when you get your assignment, this is what you will see. This circle slowly moving down and to the right. And then there's some options over here for like, okay, if I click this, I can draw the circle. I can click this button to reset the circle. I can change the radius of the circle. I can change the color of the circle, etc. You can't really see the circle there, but trust me, it's reset color. Down here in the bottom left, this is kind of hard to see, but it says sample text. And if I change this and then I hit set text, it will set that text to something different down there. So this is the IMGUI user interface that you can use within any OpenGL application. And it turns out that SFML is actually built on top of OpenGL. So there's a version of the IMGUI library built specifically for SFML, and it's super easy. And trust me, this will be the easiest UI library that you have ever used. I promise you that. That's the one thing it has going for it, is it's super simple to use. But that is not the solution. That is the skeleton code that I've given you to start your assignment. So let's have a look at the solution. So I've pre-compiled a version here. So if I go A1 solution, Mac M3. All right, here is what your program will look like once you have actually completed it, hopefully. So you can see here that there are a number of different shapes, and the properties of all of these shapes have been defined in a configuration file. So this is really, truly just an introduction to C++, file reading, setting up the window, drawing basic shapes, and using some basic things in the user interface. So here, for example, if I click this shape drop-down menu, I can see all of my different shapes here. So if I click on the red one, I can see that the properties of the red shape are now being displayed here. And if I decide to bump up the scale of that, so in graphics terminology, the scale is a multiplicative factor on the size of something. And in SFML, we're going to see in the next lecture, I'll go into a tutorial about IMGUI, about SFML in depth. This is just like giving you the assignment stuff. But you can just say set scale. And if you set scale 2, the thing will be twice as big. Really, really easy. Also, you have the velocity here. I can change the velocity. So here I've changed the Y velocity of the red shape to near 0. So you can see it's not going up and down as fast now. I can change the color. So this color picker is just like 2 lines of code in SFML. And now the thing that's called red is now some deep shade of purple. And I can also come in here and change the text that's being displayed. So now it says red 55. Okay, so that's basically it. I can also toggle the drawing of the shape on and off here. You can see it disappearing. And so this is the introduction. Oh, and the last thing is that that text has to be drawn centered inside the object itself. So this is kind of a basic assignment. There will be a couple of tricky things, especially if you've never used C++ before. I'm sure you're going to come across a few compilation errors at some point or some syntax while you're learning the SFML library, but it's not so bad. There's a few things to do, but it's a relatively simple assignment. Okay, so I'm going to close this down now, and I am going to go into the README file, which is going to explain in detail exactly what you have to do for this assignment. So I'm just going to read it all, and we'll find any mistakes that we have. So COMP4300, assignment 1. So some notes on the first assignment. I won't really have to read this again. This top notes section is going to be the same for every assignment that I give out. I just copy and paste it there to make sure that everyone does it correctly. And it says, note, you will be required to submit main.cpp and no other files for this assignment. Submission will take place on D2L's Assignment 1 Dropbox, so I'm sure you've all submitted assignments via D2L before. There's nothing new to that. Working solutions are included with the assignment so that you can see what a correct solution looks like. These executables are located in the bin directory and are provided for 64-bit Windows, and I'm going to try to have them provided for 64-bit x86, or sorry, not x86, but x64 Windows and Linux as well. Mac and Linux as well. So you should be able to see a solution working executable no matter what operating system you're using, but at the very least, it will be for Windows. This section here is kind of funny because you'd be surprised how people submit things. Submit only main.cpp and no other files. Don't put main.cpp inside a zip file. Don't copy and paste it into a Word doc. I have actually had that happen before. I don't know how that happened. Don't submit any project files or Visual Studio files or anything like that. Only submit main.cpp and no other files. Now, that's kind of a legacy thing because on D2L now what I can do is actually specify you can only submit one file and it has to be main.cpp. Okay? In the future, the only thing that will change about this is that instead of submitting main.cpp, you'll be zipping the source directory and submitting the zip file. Okay, so that will be the only difference in future assignments from this assignment with respect to how you submit it. Now, I do recommend that you work with a partner in this course, and if you do, everyone who submits must include the following in a comment at the top of main.cpp. Both of the students' full names and student numbers. And if you didn't get a specific feature to work, such as text centering or whatever, explain what you tried to do, because I'm a big believer in giving partial marks if I think you have actually tried, right? Most of this is about the effort, the trying to get things done, and if you get almost there, tell me what you tried, tell me why you think it didn't work in that comment, and we can see about giving some partial marks. Just to clarify, if you are working in a group, only one person from that group submits the assignment. Okay? Make sure that that person actually submits the assignment, because sometimes that has happened where, the partner said they would and there was an error or something. So just make sure that one person submits it. I don't care who submits it. You'll both get the exact same grade, unless someone comes to me later and says, hey, this person didn't even show up, they didn't do any work. We'll talk about that if it happens. But yeah, you have to make sure that both students' information is included in that so that I can tell who the partner is of the non-submitting member of the assignment. Now, if they forget when they submit and you come to me later and we talk about it, nothing is set in stone in this course until grade submission sometime in December. Okay, so if there is ever an error, just come talk to me. It's no problem. We can fix it. I have control of all that, so don't worry about that. But make it as easy as possible on everybody and make sure to include that information. Okay, now for the program specification. I'm going to just start reading it. In this assignment, you will be writing a C++ and SFML program which will read descriptions of shapes from a configuration file and then draw those shapes to the screen. Each shape will have a name, position, speed, color, as well as properties unique to each type of shape. For example, a rectangle will have width and height, and circle will have radius. For this assignment, the position of a shape refers to its SFML default in the upper left corner of the shape. So, I do not have a diagram of this, but I'll explain this more in the next lecture. But essentially, so all the math you've been taught, probably when you see an XY axis, 0, 0 is in the bottom left corner, right? And X increases as it goes to the right, and Y increases as it goes up. But in most graphics languages, and SFML is like this, 0, 0 will be in the top left corner. So X will increase as it goes to the right, and Y will increase as it goes down. Okay? So the unintuitive thing about most graphics libraries, if something is below something else on the screen, then its Y value is actually higher, not lower. Okay, so just keep that in mind while you're programming. And the position of something in SFML by default refers to the top left corner of that. But I'll get into more details specific to SFML and IMGUI in the next lecture. So if I go over here and look, you are given this configuration file. So that's in the bin directory, and we have config.txt. And so this config.txt specifies, as you can see here, the window size. So by default, it's 1280 by 720. Feel free, if your laptop resolution or if your computer monitor size or whatever doesn't work for this default size, feel free to change that. You will not be submitting the config file when you submit your assignment, so you can make any changes that you want to this. Just make sure that when you go to submit it, you set it back to the defaults to see that it at least works, right? So if you've got some huge resolution and this window ends up being really small while you're developing and working on the assignment, change that to something bigger. The properties of the assignment shouldn't really change all that much, okay? And then we specify this font here, and then we specify a few circles, and then we specify a few rectangles. I've got stuff in the README file about exactly what all these numbers mean, so I'll wait until I do that to explain all of those. But let's go back to the README file. Oh wow, this got super big. Okay, so that's the config file. You are also required to make these shapes bounce off the sides of the window which contains them. This means that if a shape's left side hits the left side of the window, its Y speed reverses, or its X speed reverses. If the top of the shape hits the top of the window, its Y speed reverses, right? So this is essentially how you would make something bounce. If you detect that it has touched one of the sides, you just flip the velocity of whatever direction it was heading to hit that. Similarly, the opposite, if it hits the right side or the bottom side of the window. You can assume that all shapes will always be configured to start entirely within the window, and you don't have to worry about what happens if they start outside the window. Each shape's name should be drawn on the exact center of the shape in the given font size and color specified in the file. Note that exactly centering the text might be the trickiest part of the assignment, but if you've got it kind of centered but not exactly centered, you're not going to get a 0. You might lose like 5 marks or something like that. Okay, so let me go over here and run this again to show you what I mean. So here, if I want to change one of these velocities super low. So this is the green one, I believe. Okay. So by the way, you can minimize this if you want to. And now hopefully this works. Sick. Okay. So here, the green one, you can see that the middle of the text is centered exactly in the middle of the circle. What I suspect that most people will find at first is that instead of being centered exactly, it's going to kind of be centered a little bit, like maybe it's up by half or down by half or something like that. So just keep in mind that that's what the assignment wants, is the center of the text should be in the center of the circle. Okay. Back to this. You are also required to implement an IMGUI user interface, which is able to do the following things. So it should list all the shapes and select any one of them to edit their properties, toggle whether or not the selected shape will be drawn, change the scale of the shape between 0 and 4, change the X and Y velocity of the shape between -8 and 8, change the color of the shape, and change the name of the shape. So that's what your UI has to be able to do. And just note, do not worry if rapidly changing the scale parameter causes the shape to go outside the bounds of the rectangle. Assume that it will only be changed to remain within the rectangle. The newly scaled shape should properly bounce with its new size. What does that mean? Well, let's just give you a demo of exactly what that means. So over here, for example, if I take this green shape and wildly scale it when it's about to interact with the side, then the math screws up, right? So you can see here that this is not what I wanted, because what I did was I made it so big that it actually went past the side of the window. So if changing this scale value rapidly in that way makes it so that it goes past the side of the screen, don't worry about that case. I don't want you to solve that case. But if it's completely within the bounds of the window, I do want it to be such that the newly scaled version will correctly bounce off the sides of the window. Okay? And don't worry if, don't handle the case of where the config file may specify that the shape starts outside the window. You can assume that all of the shapes will correctly start within the window. A sample configuration file is given to you in config.txt. However, marking will be done with an unseen configuration file in order to test it more completely. Be sure to add and remove your own shapes to this file to test if they all work correctly. What does that mean? Well, it means, for example, if I go over here to the config file, by default, it specifies like the window, the font, the circles, the rectangles. We could have that specified in any way. Okay? I could have 20 rectangles. I could have 0 rectangles. I could have 0 circles or rectangles, right? So don't assume this. Properly loop through the file and detect how many there are, store those things in some sort of container. And so just keep in, and so when you go in and you think you've got your solution like correctly working, like delete these and see if that works. Delete some more, see if that works, right? So we're going to be testing with a different configuration file than the one that you have, but by far the most important thing is that it works with the one that we gave you. Each line of the configuration file specifies one of the settings of the assignment program, with the first string in each line being the type of setting that the rest of the line specifies. Lines in the config file can be one of the following types, and lines can appear in any order in the file. So, as you saw before, the very first string that appears in the file specifies what this file is meant to configure, right? So for example, window means that, hey, there's 2 numbers about to come. One is the X size of the window, one is the Y size of the window. Font means that the font stuff is about to come, circle means the circle stuff, and rectangle means the rectangle. And in the README file, I've got the exact specification of that. So if you see window as the first token, then the following 2 things on the line will be W and H, where W is the width and H is the height, and they'll both be integers. And we'll show in a second how we actually set that up in SFML. There's a question? No. So lines in the config file can be one of the following types, and the lines can appear in any order in the file. Yeah. But we probably, I want you to be completely arbitrary in how you read it, but we'll probably only be testing it with window being the first thing in the file. So if you absolutely can't get it to work, it should be fine if you assume the first one is window, but try not to let that happen. The next type is font, and font comes with a bunch of different parameters. And so this line defines the font which is used to draw the text for the program. The format of that line is as follows. So the first thing following font is F, and F is a string with no spaces specifying the font file. Next is the size, S, and then followed by 3 integer values, R, G, and B. Okay, so if you've ever done any work with any colors before, you know that each color has RGB. That's how we specify colors, at least in the RGB space. And so if we go back to config, we see font, fonts/tech.ttf. Some people have asked me, why did you choose this font to release with the assignment? It's because it was the smallest font file that I could find that was like, that looks reasonable. So it's a nice monospace font that's only like 10 kilobytes or something, really small. Then you see 18, so that's font size 18, and SFML will have all the options to be able to set the font size really easily. And then you see R, G, and B, which are 255, 255, 255. And what color does all 255s make? White, okay? And so SFML specifies its colors, its R, G, and B values between 0 and 255. If you're used to HTML and CSS development, you've probably seen colors specified in hex codes. And those hex codes, those 2 hex values are 16 times 16, which is 255. And so if you translate those hexes into integers, that's exactly what you're seeing here. One of the annoying things that you will find on this assignment, and I'll talk to it in a little bit, is that IMGUI specifies its RGB colors from 0 to 1, with 1 being the maximum value, whereas SFML specifies colors from 0 to 255. So there's just one little conversion that you have to do, but everything else matches up really easily. Then there are rectangles and circles. So rectangles have all of these parameters. And so the first thing is the name of the shape. So that's the string that you have to load to draw inside the shape. Next is the initial position, x, y, in the window where this shape will appear. Then we'll have sx, sy. That is the speed in the x direction and the speed in the y direction. That's going to be the velocity. And these are given as floats. Then you have RGB. That is the color that this shape should be drawn with. And then the size, and that is going to be width and height of the rectangle. Okay? The circles are similarly specified, except circles don't have widths and heights. They have radius. Right? So the circle is exactly the same, except it's a radius. So if I go back to the config file real quick, I can see, okay, rectangle, I've named this rred, just for rectangle red. It could say, I don't know, it could say Windows 95. It doesn't matter what the string is. I just named it so that when you're debugging your program, this has a name which is associated with the color, so you can say, okay, that's not red. Why isn't it red? Right? Then we have 200, 200, and what was that? That was the initial position within the window. So this rectangle will appear 200 over in the x and 200 down in the y. Then we have sx, sy. That is 4, 4. And this is the speed in the x direction, the speed in the y direction. And the speed for everything we'll do in this class is essentially measured in pixels per frame. And we'll get into more of that, exactly what that means. But every time you draw a new iteration of the window, and we'll go into the code to show this, you're essentially going to update the position by adding the speed to its position. So if it started out at 200, 200, on the next frame, it should be at 204, 204 if the speed is 4, 4. So you take the positions x, add the speed x, you take the position y, and you add the speed y. Did I see a question? Yep.
Yeah, sorry, are there parameters to configure the layering of the shapes?
So that's a really good question. And in case the mic doesn't pick it up, the question was, how do you affect the layering of the shapes? By default, what happens is they are layered in the order that they're drawn. And so just as if you were painting an actual painting, whatever you paint first will be overwritten by what you paint next. And so later on in the class, we'll talk about some solutions we can have for how to order the rendering of things. But for the first assignment, it won't matter at all. Okay? Well, just whatever order you happen to load them in and draw them in, that doesn't really matter. Next is RGB and then width height. So RGB here, red will have 255, 0, 0. And as RGB, 255 is the max value, so this is the maximum pure red color. And then we have the width and the height. So this will be 50 pixels wide and 25 pixels tall. That's the rectangle. And if we look, these circles are the exact same, except instead of a width and a height, the purple circle will start with a radius of 75. And again, the radius is half the diameter, so just keep that in mind while you're doing it. Any questions at all about the configuration file? Yeah, in the back.
If we set the name of this as C green to R green, will it become a rectangle?
No. So the question was essentially the naming doesn't matter. The only names I've given here are so that the default, when you go to debug your program, like, you know, the red one looks red. The one that's named purple is kind of purple. The one that's green is green. But again, the name can be anything. It doesn't have to be related to the color whatsoever. I've just done that so that, like, yeah, so if you change C blue to R blue, it doesn't change it to a rectangle. It remains a circle. It's just that's the string that is associated with that thing. Another question?
Do the names have to be unique?
So the question was, do the names have to be unique? You can assume that they are unique, if that helps you. So for example, if you end up storing like a map from strings, actually, don't assume they're unique. I don't want that to be a thing. So yeah, they can be anything. They could all be blank. Well, they can't be blank in the config file because that you wouldn't know what to read. But yeah, you could store a blank string there. You could store just an underscore, an @ symbol. They could all be the same. Yeah, good question. Yep.
Are circles and rectangles the only shapes that we're going to have to account for?
So the question was, are circles and rectangles the only shape? In assignment 1, yes. Yeah. And in fact, in assignment 2, we'll be doing multi-sided polygons. And it turns out they're just circles. So circles cannot be drawn on a computer screen, believe it or not. Every circle you've ever seen on a computer screen is an approximation of a circle. Because the definition of a circle is an infinite set of points equidistant from the center. And you can't draw an infinite set of points on a screen, right? Because there's a limited number of pixels. And so what we do is we draw a bunch of lines. And it turns out if you draw a circle with 3 lines, you get a triangle, right? And if you draw a circle with 8 lines, you get an octagon. And so we'll get into that more. But yeah, we'll just be doing circles and rectangles for assignment 1. Good questions. Anything else? Yep.
String is too big, some other shape. How is the problem in tackle that?
As long as it's centered, I don't care how big the font size is. And that's just such a minor point because like it should work with whatever font size you give it. Yeah. And yeah, if the text is bigger than the shape, I don't care as long as it's centered properly. Yeah. Okay, so let's move on a little bit. Let's get into some assignment hints. I always like, there's a bunch of things to do in these assignments, right? So you may get a little stuck on like, how do I store these shapes? What do I do first? How should I approach this? So I always give some hints. So first hint, in order to store an arbitrary number of shapes from the configuration file, you must store them in a container, right? So one of the mistakes that I see people do is look at the config file and say, oh, there's 3 circles and there's 3 rectangles. So they make 3 variables for circles, they make 3 variables for rectangles. But be sure that we will be testing it with an arbitrary number of circles and rectangles. So you must read them in, an arbitrary number of them, and store them in a container. Now, each shape that you're going to be drawing to the screen has a number of details associated with it, right? So if I go back here and I run it again, you can see here that the green shape has a bunch of these properties, right? So it has first whether or not I should actually draw the shape. So if I click this, the green shape disappears. It has a scale associated with it. It has a velocity. It has a color. It has a string associated with it, right? And so some of these properties are able to be stored in the SFML shape class, but some of them are not. And so what this hint says is that I recommend considering creating a custom class or structure which stores all of the properties of a shape that you want to store here, right? And then create a container of that custom class that you've made. So you could create your own custom circle shape that has a string, that has a velocity, that has a Boolean, whether or not it should be drawn, and then create a collection of those. This is a hint because the hardest part about learning any new library is like the syntax and figuring out what all the function calls are and stuff. So a shape will touch the side of the window if its bounding box makes contact with it. Each shape's bounding rectangle can be obtained via shape.getLocalBounds. I'll go into this a bit more in the next lecture, but shape.getLocalBounds will have a top, a left, a width, and a height. And you might say, okay, that makes sense for a rectangle, but what about a circle? Well, it turns out that a circle also has a bounding box. It's the smallest rectangle that you can possibly draw that contains that circle. And it just so happens, luckily enough for our assignment, that if you draw a rectangle, meaning, well, if it's a circle, it's going to be a square, but it's still a rectangle. If you draw a rectangle around those circles, and you compute when the rectangle would intersect with the sides, that is the exact same as computing when the circle would intersect with the sides. Why? Because the circle will only make contact with the sides of this window when it touches the exact left, the exact top, the exact right or the exact bottom, just by the nature of circles. So if you get the bounding box of that shape, that is sufficient to tell you when it's going to be intersecting. And the cool thing about that is that the collision code for the circle ends up being the exact same as the rectangle. Okay? You could also, for the circles, say, okay, I can figure out the position of the middle of the circle and then figure out how close I am to the sides via the radius, but it turns out you don't need to do that. You can use the same as the rectangle code. So there's shape.getLocalBounds, shape.getGlobalBounds. Play around with those, see what values they give you. Similarly, in order to draw text in the assignment, you're going to have an SF. So SF is the SFML's, that's the namespace. So you can say SF text, SF shape, SF window, all that kind of stuff. And SF text's elements bounding rectangle can also be given by that function. So if you have a text object that you set up with a font, and we'll show the code in a second, you can say get local bounds, and it will give you the bounding box of the text. So the only math you really have to do is say, okay, I know the rectangle position and size of where the shape is, and I know the rectangle position of size of where the text is, so now just move the text up by half of it, like down and to the right by half of the size of the rectangle, right? So not too difficult. And just make sure that you are using C++ file reading rather than the C-style capital file reading. Okay, you will lose marks if you are using functions that are old C functions. And if you need tips on how to do C file reading or C++ file reading, please don't go to ChatGPT and say, how do I read from a file? Watch the live coding session from my C++ lecture, because I do the exact type of file reading that you need for this assignment in that. Okay, I literally do all the file reading that you need in that lecture. So just go there, watch that, see that sort of progress from nothing to having all this stuff read, and you'll be able to do that. Okay, so now we've looked at the config file, we've looked at the README file, so now actually let's go into the source. So make sure I don't open the solution file. Oh, if you are developing on Mac or Linux, you will see files appear inside the source directory. And so these are the intermediate build files that Make produces. And so here you see main.cpp, but you also see main.d and main.o. And so you can delete all the intermediate build files by typing make clean. So if I type make clean, oh, I'm not in the right directory, sorry, make clean. It will remove all of those intermediate files, and now those files are no longer in this directory. So if you want to get rid of all those files, that's what you do. Just type make clean. All right, so main.cpp, let's have a look at what's in here. So the first thing we have is we have all of our includes. So up here, these are the STL things that we're going to be using. So we have IOStream for input output. We have FileStream for reading and writing the files. I'm not sure what I've included memory for. That may or may not be necessary. Here I include the SFML graphics library. We won't need any of the audio stuff or anything like that for this assignment. And then I include the IMGUI and IMGUI SFML library. So all the things that we need to import are there. Next we have our main function. So here, this is going to, I'll just go through the code that I have, explain it a little bit. I'll go through this very quickly because I still want to get to the assignment setup. And then on Tuesday's lecture, I'll go into this in great detail to give you sort of a tutorial for the assignment, okay? So what we do here is we set up a width and a height variable. You're going to be reading those from the file, right? I've just hard-coded this. Then in order to set up a window in SFML, we just very simply say SF render window. This is the window that we're going to be rendering to. And I have to pass into that a video mode. So a video mode would specify things like the width, the height, whether or not it's full screen, whether or not you can minimize it, etc. And I give it this, this title. Next, I set a frame limit. And so frame limits are important because this says what is the maximum frames per second that this will run. It doesn't set a minimum. It turns out you can't possibly set a minimum frame rate, right? Because your code may end up taking too long to run in that. that amount of time, but you can set a maximum. And if you delete this or you change this, your shapes will be bouncing around at different sizes, because in this first assignment, all of our logic is running at the same speed as our rendering, right? And if logic runs at the same speed as rendering and we change the FPS, we actually change the speed of the program. We'll talk about how you decouple those things much later in the course. But just keep that at 60 for now. In order to use IMGUI, it needs to know some information about the amount of time and stuff has passed, so we just set up these variables for IMGUI. Next, the default IMGUI user interface is actually quite small. The default IMGUI UI is actually half the size of this. So it's very, very small. So what I've done by default is had these two lines of code here, which this scales the UI elements, and this line scales the fonts. Okay, so what these two lines of code do is essentially just scale up everything so that it's twice as big. And I find that just a little bit easier to use. Next, we're going to set up the variables that we will use to store all of the things that we want to be able to change with the UI, right? So, actually, I'm using I want the student one. So yeah, by default, what I'm doing is I've given you this skeleton code, which hard codes all the properties of a single circle. And what you're going to have to do is read in all the different shapes and make this, put it in a loop, put them in a vector, etc. So that's what I'm doing here, is just setting up a single circle. So I set up a circle radius of size 50, circle segments, that is what SFML uses to draw the circle itself. So there will be 32 individual lines to draw the circle, and that's about the point where the human eye can no longer tell that it's a polygon and it looks like a circle. The circle speed X and circle speed Y, what I've done here is set, okay, every time we redraw the window, it's going to move 1 pixel in the X direction, and it's going to move 0.5 pixels in the Y direction. And you might say, what the hell is half a pixel, right? If you're into like speed running or retro gaming at all, you may have heard of the term subpixel. That's essentially what this means, is that the actual position of this thing in the world is being stored at a floating point resolution. But then when it goes to be rendered on the screen, it just rounds everything to the nearest pixel, okay? So it will actually take 2 times 1/60th of a second to move it by 1 pixel in the Y direction. Then I have a Boolean, which is draw circle. I have a Boolean, which is draw text. Those are both just set to true, and then those will be tied into the UI somehow. Then I'm going to create an SF circle shape, which is really simple to do. You just say SF circle shape, give it a name, and then into the constructor you pass the radius and the number of segments. Then I am going to set its position to somewhere that I've hard-coded. Again, all these things you'll be reading from the configuration file. So I just say the top left of this circle is going to be at 1010 in the window. So if I run it again, 10 pixels to the right and 10 pixels down is basically right up in the top left corner. And then it's moving twice as fast to the right as it is going downwards, right? So you can see it's not going in a completely diagonal line. Then I load, yeah, did you have a question?
So the file we're looking at right now, are you saying the code will be very similar? Instead of hard coding it, we're just going to be reading from the configuration file?
Yep, so you're going to be given this, and then you'll edit it so that instead of just drawing this one hard-coded circle, you're going to have a function that you write or something. You're going to have some way that you store all the data for all of your shapes. You're going to set that up, and then you're going to go through the configuration file. Oh, look, I have a new circle. Read in all its properties, add that to the container of circles that I currently have. Yep. Then what I do is I set up a font. I try to load from that font from a file. So you may not have seen syntax like this before. What does if not font.load from file mean? Well, the load from file function returns a Boolean of whether or not it was successful, right? So instead of saying bool successfully loaded file from font or font from file equals this and then checking it, we can just do it all in one statement. So if not have I loaded the file, then I would have an error, right? So if, this is just basic error checking that you don't have to worry about. I just wanted to show you this example. So if I can't find the font file, just do that. Oh, and because everything in this assignment is being loaded all of the file reading is done assuming that you've run the executable from the bin directory. Okay, so let me very quickly go over here and I'll get out of the bin directory back into the top level directory of the assignment, and then I'll say bin/A1 student. Okay, so if I try to run the executable from a different directory, it tries to read the font file from a local directory called fonts, and it doesn't exist. So when I run it, I have to make sure that I cd into bin and then run it from there. Okay? But it turns out that that's super tedious, and I'll talk about this in a second. So I've just set it up so typing make run compiles and runs the program in one command. So you don't need to do all this changing of directories back and forth. Okay. So that's loading the file, the font, and now that's the font that will be used to draw the text, but now you actually have to set up the text element in SFML. So you say sftext, make a variable. This is the string that will be drawn. It will be drawn using my font, and it will be drawn at this size. Okay, so you'll be reading those from the config file. Then you're going to use setPosition to draw that somewhere on the screen, and because I want it to look like it's on the bottom of the screen, I have put it at 0, height of the screen, but since this is the position of the top left of the text, I have to subtract the height of the font. And so that's the function I would use to get the font, which is the character size. And then this sample text, this is how I'm going to set up. IMGUI uses character arrays for its text, and I'll get into that in a bit. Okay, now we're going to talk a little bit about the main loop. So the main loop of any game is the most important part. And here, essentially what we're doing is we're saying, while this window is open, clear the screen and redraw everything. Clear the screen, redraw everything, do the logic. Clear the screen, do the logic, redraw everything, right? So that's our main loop that we're doing. So this here is event handling. So event handling on the window, I do things like, hey, if I detect that the window was closed, actually close the window. If I detect that a key was pressed, do something if I want to. Again, I'll get into this like SFML event handling stuff a lot more in the next lecture. Then I have to pass this command into IMGUI, which we'll talk about next lecture. And here is where I draw the UI. IMGUI is so crazy simple because if I want to have a checkbox that modifies a variable, I just pass a pointer to that variable into the constructor of that checkbox. And now when I hit the checkbox, it toggles that on or off. Similarly, if I have a slider, like if I have a slider float for the radius of something, I just pass it a pointer to a float, and whenever I move that slider, it directly modifies that value in memory. And so it's so simple to set these things up, and again, I'm going into much more detail about this in the next lecture. So this will draw the UI. You will, of course, have to modify that to have something that reads all the different shapes and does something with the UI. Then I set some properties of the circle. I set the color of the circle based on the color slider that I set up in IMGUI. And then I have the drawing calls. So the drawing calls are super simple. Window.clear. If I don't call window.clear, what will happen? That's actually pretty interesting to look at. So let's do this. If I don't clear the window, it doesn't clear the window. It's actually like a paintbrush, right? And so we got to clear the window. This does take a color argument, but by default, it's black. So if we set nothing, it will clear the screen to black. And then what happens is I draw the circle, if I should draw the circle, and then I draw the text, if I should draw the text. And then I make the call so that IMGUI actually gets rendered to the window, and then I call window.display. And I'll get into the details of what that means, but that essentially means draw it all or post it to the screen. And the basic animation that I do is every frame, I take the circle's speed, add it to the position, and that is the new position of the circle, okay? So this main loop just says, while the window is still open, take the circle's position, add the circle's speed to it, and then redraw the circle, okay? And you're just gonna have, instead of drawing this one hard-coded thing, you're gonna have a loop that goes over your container of all the shapes and does that in the assignment. So that it's pretty simple, but as a first assignment, it really is just a test of, okay, can you get a handle on C++, etc. And I've only got 20 minutes left, so I want to use all that time talking about the setup. So let's get into that now. If you have any questions, any more questions, I'll be happy to answer them at the end. So I've included this environment setup file. You can download SFML up here. That is a link to download it. There are some SFML tutorials here. I will be going through some of the pages of those tutorials in the next lecture. But Linux is the easiest to set up, so I'll go through the Linux instructions first. Here, I've included a bunch of stuff like this. These are the commands that you'll have to type. Just a quick note is that don't actually type that character. I'm using that character to denote that this is a command that you would type into the terminal, right? So first you have to install GCC, make, and SFML on your system. So here you have the command to do that, sudo apt-get install. Of course, this is if you're using Ubuntu. If you're using another distro, it's the same. The libraries are named the same, but you may have a different command to install the libraries. So this will install everything that you need. Then you will extract the assignment zip file into some directory. Then you will go into the assignment's root directory, meaning not any of the subdirectories like bin or source or whatever. Then you compile the program by just typing make, okay? That will place the executable into the called SFML game into the bin directory. Then you change directory into the bin directory and type /SFML game to run that thing. So let's have a look at that. Here we have a Linux terminal. I am inside the root directory of that assignment. I have a make file here, so I am going to first type make clean. That makes sure that anything I've already done is removed. Now I'm going to type make. It's going to compile everything. The vast majority of the compilation time here is the first time you compile. It has to compile IMGUI, but every subsequent time that you just compile your main.cpp, you won't need that. So then I'm going to cd into bin, and now I've got this /SFML game that I can run, and you can see here it runs under Linux, no problem. That gets a bit cumbersome. So what I've done is I've specified a target in the make file that if you type make run, it will compile it, and if it was successful, it will detect that, cd into the bin directory, and run it for you. So typing make run is by far the easiest way to do that, and that's about it. It's real easy. So that's it for Linux. If you want to remove all intermediate bill files and the executable, you would just type make clean. And if you decide to use Clang instead of G++, you just need to change the make file. So that's it. Linux just works. Mac is similarly easy. So the first thing you need to do, and I completely realize that this program called Xcode exists. I will not be officially supporting Xcode. I am going to be recommending that if you're doing this in Linux or Windows, or Linux or Mac, let me actually just close VS Code here. So here I am in my assignment directory. How would I recommend doing this on a Mac or Linux? Just use VS Code by typing code dot. That will open VS Code, open to this directory with all the files. Then you make changes to your code, and you can either switch back over to the terminal and type make, and that will compile your changes. Or what you can do, oops, didn't mean to open that, is come back over here, and you can open a terminal right within VS Code, and then you can type make run right from here, and then it'll just run it. That may be the most convenient thing for you to do, but since I'm running on such a blown up resolution here for the video, That's why I'm using the terminal. Or you can close the terminal here if you want. So that's my recommended development cycle, is make some changes, make run, make some changes, make run. That's Mac or Linux. So Mac, first you do need to install the Xcode build tools. That is a requirement. So you would just type xcode-select-install, and then you need to install brew or homebrew. And so homebrew is like a package manager for development in a Mac, and you do need to install them in this order. So the Xcode tools first, and then brew. Once you have brew installed, then you can use that to install SFML. So brew install SFML. Then what you need to do is you need to make one change to the make file, and that is where brew installed SFML to. I think in 99% of cases, if you're using Mac Silicon like M1, M2, M3, you won't even need to change this. It should go to the correct place. But in case there are errors, you need to type brew info SFML. So if I come over brew info, info SFML, this will tell me where it's installed. Opt homebrew seller SFML 2.6.1. And so that's what I've set up as the default in the make file. And so the only thing you might need to do on a Mac for the make file is come over here. So I've got the Linux command line arguments and the Mac command line arguments here in two separate things. You may need to change this if it is installed somewhere else on your system, but that's it. On Linux, you won't need to make that change because Linux it just knows where it is. And then what you do is everything is the same as the Linux instructions in terms of how to make and run the assignment. Okay, so just go back up to the Linux instructions and read from there. Windows, on the other hand, is Windows. So it's a little bit more cumbersome. And just before I get started with this, there is a package manager for Visual C++ and Visual Studio called VCPKG, or VC package. I do not recommend using that for this course. If you've already got that set up and you're a pro C++ developer, that's fine. But there's a lot of overhead to that. Sometimes installing some libraries doesn't quite work correctly. So I would recommend the manual install that I'm about to go over, because it's super simple and I know that it works. And if you get any errors, I know that it's because you made a mistake, not because my instructions are wrong. So I am not going to be offering help configuring or debugging VCPKG, so please don't use that for this course. Step number 1, download and install Microsoft Visual Studio 2022 Community Edition. That is the free version. It is completely free, except you may have to just sign into it with your Microsoft account. It'll complain after you've opened it a couple of times, hey, please sign in your Microsoft account, but the free version is completely fine. And unfortunately, Microsoft, in its infinite wisdom, has two programs, one called Visual Studio Code and one called Visual Studio. They couldn't be more different. Okay, they're both kind of IDEs, so they're similar in that way, but they're completely separate programs. Visual Studio is a Microsoft program that contains the compiler and a huge IDE, debug tools, everything. Okay, so you have to install that. If I come over, I'll run it in a bit and I'll show you it in a bit. Then what you have to do is download the latest 64-bit version of SFML. So I've linked directly to it here. So you can just click on that, or you can go up to the download page and download it from there. But make sure it is SFML 2.6.1 64-bit version. We're doing the 64-bit, not the 32-bit version. It will not work if you get the 32-bit version. Then you extract that zip file to a directory on your computer that contains, ideally, no spaces in it. And the reason for that is because we're using a Windows environment variable. Sometimes they have problems with spaces. So I do, despite the fact that I'm using a Mac laptop, because I like the Mac laptop, I use Windows for most of my development. So what I do is I have a directory on the C drive called dev, and then I have some subdirectories. One is called libraries, one is called code, one is called languages, stuff like that. So I would recommend C, dev, libraries, SFML-2.6.1. So then you know where it is. But you can put it anywhere. You don't need to put it there. That's just the example that I'm going with for this tutorial. Then what you're going to do is you're going to create a Windows environment variable. Why? Because the project file for your assignments use that environment variable to know where your SFML has been installed to. So it just uses this variable. And I'll go over how to do this in a second. Then what you need to do is a second step of you add the bin directory of SFML to your path, because there are DLL files that are required for SFML. And so DLL files are dynamically linked libraries. They are loaded at runtime, and this is how you do that. So let's really quickly go over here. I've got my assignment open in Windows, and to create these environment variables, what I do is I just type env, and the very first thing that comes up, I hit enter. Then I go to environment variables. I apologize for this being so small, but again, it's a VM scaling issue. So what I've done is I've created an environment variable here called SFML_dir in all caps, and I have just put in the directory where I've extracted that SFML zip file. That's it. And then for the path, what I've done is I have put in path. Have I done it here? So what you do is you put a new thing in the path, and this is just SFML_dir within percentage signs. That is how you would load that variable that you just made, /bin. That's it. So you've set all of that up. Now when Visual Studio is launched, it knows where SFML is. Okay? So let's go back. So you've done those two things, and in Windows, environment variables are read at the time the program is launched. So if you had Visual Studio running, you need to close it and then reopen it. Then you download and extract the assignment zip file, navigate to the Visual Studio folder, double-click sfmlgame.solution, and then if any warnings show up, just click OK. They shouldn't, but you'll be fine. Oh, make sure if you had Visual Studio installed, just do an update so it's the most recent version. Then in Visual Studio, switch from debug to release, and then right-click SFML game project and click build. So there's two different modes of building in Visual Studio. One is debug. It is an excellent way to debug your program, setting breakpoints. It's an amazing visual debugger. It's the reason I still use Windows. It's so good, it's just great. But if you want to run your program without debugging it, I would just click release. It's much faster. So when debug mode is running, it's keeping track of all the memory, which can slow down your program like literally 100 to 200x. So it can be running very slowly if you're in debug mode. So just click to release. Click release and then build. If everything was successful, no errors should pop up. But to do all of that in one click, just click local Windows debugger and it'll run, compile and run for you. If it says graphics.hpp was not found, then you did not correctly set up the SFML library. One of the most common things that I see is that some people extract the directory into kind of a double directory, where you'll have a directory SFML-2.6.1, and then inside that directory, they'll have another directory SFML-2.6.1 if they had extracted it improperly. So you did that step wrong if it says this in the output. If it says DLL not found, then you didn't properly add that bin directory to the path. So let's just have a look at what that looks like in practice. So once the setup is done, Windows is fine. It's not hard to use. So Visual Studio directory, double-click sfmlgame.sln. It launches Visual Studio. It loads everything. It knows where SFML is. Here we are. So I can build it in one of two ways. I can right-click here and then click Build. And then in the bottom, in a very, very small font, I apologize, it will... Oh, Jesus, how do I... Let me see if this works. Oops. There's some way to increase that font size, but essentially it says build, 1 succeeded, 0 failed. If there are any errors, it will show up here and then it will say 1 failed. So if you're using Visual Studio, all of your build errors will come down here. And if I want to build and run it, I can just click this button. So local Windows debugger, that will build everything, compile it, link it, and run it. And there we go. So now, this is the reason I'm not using Windows to show you all of this, because of the scaling, the window is super, super tiny. So that's all you do. You make some changes to your code. Let's go in here and let's make the height of this, I don't know, something unreasonable, and then run it again. It will recompile only the file that's changed, and now you can see that, the height of that window is much better. So like development in Windows and Visual Studio is great. But just keep in mind, this is Visual Studio, not Visual Studio Code. Okay? I do not recommend using Visual Studio Code for C++ in Windows unless you know what you're doing. And you've installed some other compiler or something like that. And that's it. That's the setup. I don't think anyone should really have a problem with that. You know, if there are any problems, please feel free to post in the public channel on Discord, and I will very happily immediately answer that as soon as I see it. I know I skipped over a bunch of the details of the skeleton code, but that's what the entire next lecture is for, is going through the SFML and IMGUI tutorials and explaining all this stuff in depth. I think that's it. So any questions that you have, I'll be able to answer them now. Yep. The what? Yeah, that will be so the question was whether or not you're going to get the setup file. Yes, that will be included in the zip file. Yep. Any other questions? Yep. Yeah, so the question was, on the assignment, the number of circles and rectangles are not fixed. It could be 0 or more of either of them. So there could be no shapes, there could be 100 of each shape, there could be 100 of one and none of the other. Okay, so you have to account for that. Yep. So for assignment 1, that's a good question. So the question was, how do you recommend splitting up the work for the assignment? I would recommend a pair programming approach where you both sit down and do it together and you think about it together. I don't recommend, you know, one person who knows C++ just doing the first assignment. In fact, in previous offerings of the course, I had assignment 1, everyone did assignment 1 on their own, just to make sure that they learned all of this. Maybe I would recommend trying to do a bit of both of it on your own and then coming together, because there's not a lot to do, and you can talk about, hey, how did you store your things? How did you create your custom class? How did you set up the UI? So I don't have specific, there's not a big division of labor in this assignment. It's kind of linear. In future ones, you might say, okay, someone do the level, someone do the code, someone do the physics, you know, someone do this. That's not this type of assignment. So I really enjoy the pair programming approach where you just sit down, both of you at a computer, choose the fastest typer, and then you just talk about it as you go.